Hello everyone, welcome back to Sulekha physics classes. Hope you all are doing well. Today I am going to start class 10th physics of chapter Human Eye and Colorful World. In today's part, I will cover refraction through prism, dispersion of white light through glass prism and different phenomena related to dispersion, like best example is rainbow formation, how rainbow is formed. So I will discuss each topic one by one. Let us start today's session. Okay. First topic is refraction through prism. You already know about refraction. We already discussed in chapter light. What is refraction? When light ray travels from one medium to another medium, there is a change in path of light. And why this change or bending of light takes place? Due to change in speed of light from one medium to another medium. So what is refraction? The phenomena of bending of light when light ray travels from one medium to another medium, right? Now another term is prism. What is prism? Prism is actually a transparent material and it is made up of glass and having two triangular bases and three rectangular surface like this one. There is one triangular base like this one, then rectangular surface like this one, okay, and then there is another triangular surface. So prism is something like this one. It has two triangular bases and three rectangular surface. One is this side, another one is backward, and another one is upward. Now light enters through this backward surface of the rectangular, it comes out through this forward surface of rectangular surface, right? But here I am going to draw only this front surface and light enters through this side and comes through this rectangular surface. So this is the front surface of the prism. Light is incident on this surface, then inside the prism refraction takes place due to change in medium and then it comes out through this surface. So here I am going to incident light on this surface. Here PQ is incident light, right? Now at point Q, here this one is air and air is what? Rare medium, right? And this prism is made up of glass and glass having higher refractive index, it is a denser medium. Now when light travels from this rare to denser medium, what happens? Refraction takes place, and when light travels from rare to denser medium, you know bending of light takes place or refraction or light bend towards the normal. So you first draw one normal. This is normal on this surface at point Q. This one is N1. Now instead of going light through this one, it bends towards the normal like this one. So this is the refracted ray QR, right? Now again at point R, what happens? Again medium is changing. Here this one is denser medium and outside is what? Air. Air is a rare medium. So again at point R, refraction takes place when light travels from denser to rare. And at this time, what is the property of light when it travels from denser to rare? It bends away from the normal. So instead of going like this one, this is the normal N2. Instead of going like this one, it bends away from the normal and it comes out through the surface through this path RS. So here RS is what? Emergent beam. So you can write first PQ. PQ is incident ray. Okay. Then QR. QR is refracted ray. Then RS. RS is emergent ray. Okay. Now you know the angle between this incident ray and normal is what? Angle of incidence I. So I is angle of incidence. Now again at this point, this R1 or R you can say, this is angle of refraction. Angle between normal and this one is refracted ray. So this is angle of refraction. Right? And then again this angle between this normal and emergent beam is angle of emergence. So in this way you draw the diagram and write all these terms. What is PQ, QR, RS, angle I, angle R, angle E. There is again these two surfaces are inclined at some angle and this one is called angle of prism. Angle of prism. Now there is one important angle, angle D. What is this D angle? Okay. Light is incident along this direction, na, PQ. So if there is no prism, it goes like this one, na, if there is no prism. But due to prism, light changes their path and it comes out of the surface through this direction, RS. So when you extend this RS, it comes at this point, right now. So this is the original direction of light and this one is the final direction of light, emergent ray, and this one is incident ray. So light deviates from its original path. This one is original path, but light comes out through this prism through this path. So there is deviation of path right now, and this angle between incident ray and emergent ray is called angle of deviation. So this term is very important, angle of deviation. Angle D is angle of deviation. It means light deviate from its original path. Original path means incident ray. So angle between this incident ray and final emergent ray is called angle of deviation. You can write in this way, angle formed by emergent ray with the incident ray due to this prism only. If there is no prism, then there is no deviation of light. This angle of deviation is only due to this prism. So angle between emergent ray with the incident ray due to prism is called angle of deviation. And there is one important relation between angle of deviation, angle of prism, angle of incidence and angle of emergence. You must remember this one. Relation is this, angle of deviation equal to angle I plus angle E minus angle A. This one is not given in your NCERT book, but still you remember this formula. Angle of deviation equal to angle of incidence plus angle of emergence minus angle of prism. It means on which factors this angle of deviation depends. How much in which direction light deviates from the original direction, it depends on which factors. This angle of incidence, angle of emergence, angle of prism, and also nature of this material of which it is made up of, right now. So angle of deviation depends on angle of prism, angle of incidence and nature of material. So in this way you explain refraction through prism. You just draw a very neat and clean diagram and define different terms related to this diagram, right? Or write all these terms and then after that you explain angle of deviation. You must write that refraction takes place here 2 points. First is at Q, refraction takes place, and again at R, refraction takes place. So in this way you explain refraction through prism. Hope it's clear to all of you. Please take a screenshot of this one. Then we move to the next topic. Now, next topic is dispersion of white light through a glass prism. You know, when light passes through a glass prism, refraction takes place. But that light has single color, that is monochromatic light. But what happens when white light passes through a glass prism? Suppose ABC is a glass prism and white light is incident on the surface of this prism. You know, white light consists of many colors. So when white light is incident on the surface of glass prism, it is divided into different colors. It splits into different colors, and this process is called dispersion. Dispersion is a splitting of white light into its 7 constituent colors when it passes through a prism. Now, why this splitting takes place? It means dispersion takes place. We discuss later on, but here this process is called dispersion, splitting of white light into its 7 constituent colors, and that 7 colors are nothing but Vivgure. I have written here Vivgure, V for violet, indigo, blue, green, yellow, orange and red. These are 7 different colors of which white light is made up of. And this band of 7 colors, which appear at this side of the prism is called a spectrum. And as this spectrum is visible to our ears, so it is also called visible spectrum, right? Visible spectrum, because we are able to see this spectrum with the help of our eyes. So now, why this dispersion takes place? You know, different colors of light have different wavelength and different frequencies, right? From V to R, wavelength increases in disorder. It means violet color has least wavelength and red color has maximum wavelength, right? Violet color has least wavelength and red color has maximum wavelength. And you know, wavelength is C by nu. wavelength changes, frequency also changes, because speed of light is always constant in air. But you know, when light ray enters in different medium, their speed also changes with the as wavelength of light changes. So wavelength is minimum for violet color, so speed is also minimum for violet color. Violet color has band minimum speed and red color has maximum speed. And you know, refractive index is what? C by V. If velocity changes, then refractive index of light also changes. Light travels with the same speed in air, but when it enters in the medium, different colors have different speed. Violet color has minimum speed and red color has maximum speed. So violet color has minimum speed, it means violet color has maximum refractive index. Refractive index for violet color is greater than refractive index for red color. Now what happens? You know Snell's law, sin I by sin R equal to some constant, and that is refractive index, right now? Okay, so if refractive index changes different for different wavelength, but I is constant, so to keep this refractive index, to keep this ratio constant, if I is constant, N changes, it means R also changes. That's why different colors has different angle of refraction. Here red color has this angle of refraction, violet color has this much angle of refraction. So this is the reason why dispersion takes place, because refractive index for different colors is different, and due to change in refractive index, deviation of different colors of light is also different. Red color deviates least and violet color deviates most. Why? Because violet color has maximum refractive index. And one point you note down, right? Deviation is directly proportional to refractive index. You note this point, okay? Greater the refractive index, greater is the angle of deviation. And here violet color has maximum refractive index. It means violet color deviates most. Violet color deviates most. Violet color deviates most, and red color deviates least. That's why red color is at the top of the visible spectrum and violet color is at the bottom of the visible spectrum. You must write these colors, okay? Red color is at the top of the visible spectrum and violet color is at the bottom of the visible spectrum, because violet color deviates more and red color deviates less. Then one question is there, why red color deviates less and violet color deviates most? Because red color has lesser refractive index than violet color, and if refractive index is less, it deviates less, right now? So these are about dispersion of white light. Please take a screenshot. Now next is recombination of white light by a glass prism, or it is also called Newton's experiment. You know, Newton was the first to observe visible spectrum of a light through a glass prism. You know, when white light passes through a glass prism, it is split into its constituent 7 colors, and that band of 7 colors is called a spectrum, and as it is visible to our ears, that's what's called visible spectrum. Now again you put one inverted prism in front of this first prism. What happens? This visible spectrum again recombines to produce white light. It means what? First prism acts as dispersion. Through first prism dispersion, it means splitting of light takes place, and in second inverted prism this visible spectrum recombines again to form white light. Recombination takes place through the second prism. Here also dispersion takes place, but the angular dispersion produced by the first prism is equal opposite to that of this inverted prism. That's why these recombines to produce white light. You think about this now. This first prism is like this one. When you join this with this second inverted prism, it acts like a glass slab, right now? And you know, inside the glass slab what happens? when light enters through the glass slab, inside the glass slab refraction takes place, and then again it becomes parallel to the incident light. So these two prism, when joined, it acts like a glass slab. That's why when white light enters the inverted prism, also white light comes out. So this is recombination of white light by a glass prism. Please take a screenshot. After that, we'll discuss about rainbow formation. Now, next is rainbow formation. Actually, rainbow is best example of dispersion of sunlight in nature. What is this rainbow? Rainbow is an arc of 7 colors produced by dispersion of sunlight by raindrops in the sky. What happens during rainy day? There are small raindrops of water droplets are there, and when sunlight passes through that raindrops, dispersion of light takes place. It means splitting of white light takes place and rainbow is formed, right? And in this way, arc of 7 colors are formed in the sky during rainy day, and this is called rainbow. This rainbow is always formed in a direction opposite to that of the sun. If sunlight is coming from this direction, and then rainbow is formed in this direction, right? How this rainbow formation takes place? Each drop acts as a glass prism. During rainy day, each raindrops acts like a glass prism. Suppose there is one raindrop, then this raindrop acts like a glass prism. And you know, when white light enters through a glass prism, what happens? Dispersion takes place. In the same way, when sunlight enters through this raindrop, at this point, refraction takes place and white light is divided into 7 different colors. Red color is at the top and violet color is at the bottom. So at this point, dispersion of light takes place. Then again, when all these colors reaches at this end, what happens? Light is totally reflected again. Here total internal reflection takes place. Total internal reflection. You study total refraction in the higher classes. You just know that total refraction is a phenomena in which light is internally reflected back in the same medium. So second is here total internal reflection takes place. Red color reflects at this point and bottom violet color reflects. So different colors. Here also all 7 colors, here also all 7 colors reaches at this point. Now again at this point, what happens? This one is different medium, outside different medium, refraction takes place. So here again this point, refraction takes place. So 3 processes. First is dispersion. At this point total internal reflection, at this point again refraction takes place, and all these light reaches to the observer's eye, and observer is able to see all these 7 colors here in the form of rainbow. Red color is at the top and violet color is at the bottom. In this way rainbow is formed in the sky, right? So you can write in this way, each drop acts as a glass prism. When raindrop refract first, what happens? When sunlight enters here, this raindrop refracts this light and disperses into 7 different colors. Disperse the incident sunlight, then reflect it internally. It is written in the NCERT book, this language. Then again reflection takes place at this point. Reflect it internally. This is called total internal reflection. And again then refract it again when it comes out of the raindrop. And again here refraction takes place. So there are 3 processes. First is dispersion, then total internal reflection, and then refraction, and at last it reaches to the observer's eye. Red color appears on the top of the rainbow and violet color appears at the bottom of the rainbow, and rainbow is always formed in a direction opposite to that of the sun, right? This point is also very important. Light is coming in this way. Here dispersion takes place, refraction takes place, refraction takes place, and then it reaches to the observer's eye. So observer human is able to observe rainbow here in the sky, right, in a direction opposite to that of the sunlight. In this way rainbow is formed. Here 3 process takes place. You must remember these 3 process. Raindrops acts like a glass prism, and you know what happened inside the glass prism. Refraction, first here light dispersion takes place, then total internal reflection, then again refraction takes place, and human is able to see this rainbow. Okay, please take a screenshot of this one. With this, I am going to end the class. Rest topic like atmospheric refraction and scattering of light, I will discuss in the next part of this chapter. Okay students, up to then, keep revising and stay tuned with this channel. Thank you.